Hello everyone. Today I'm going to give a demonstration on how to exploit a log4j or log4shell RCE vulnerability in a real-life scenario. However, before we do that, I'm going to give a short description of this vulnerability, when it was discovered, and which version of a log4j um, library is affected, etc., etc. Okay, about the vulnerabilities. Um, the vulnerabilities is classified as CVE 2021-44228. It's a critical RCE remote code execution vulnerability in the Java logging library. It's called log4j. And log4j libraries is used by many Java application to log the application uh, systems. Um, and the log4j has uh, the features called JNDI lookup, and that is where the vulnerabilities is. And when it was discovered, the bug was reported on 9th of December by the Alibaba Cloud Security team. His name is Chen Sa-jun. Essentially, he was discovered this vulnerability on the 24th of November 2021, and he was publicly disclosed on this on the 9th of December. Um, so which version of log4j is affected? Um, Essentially, anything that below 2.14.1 are affected by these vulnerabilities. So, how attackers are exploiting these vulnerabilities? Um, Attacker will find these vulnerabilities by passing the JNDI string to the victim server, and if they get the DNS query back, then that means the target server is vulnerable to this log4j vulnerabilities attack. So once they identify the vulnerabilities, and they can start crafting JNDI string and send it to the server. And when the server connect back to the LDAP server, the LDAP server can be on the attacker machine, or can be anywhere on the internet that calls log4j. Then the attacker will um, start listening um, to the reverse shell from um, the victim server. So I'm going to be demonstrating all this exploiting scenario um, in a minute. So the tool that I'll be using in the demonstrations are Kali Linux to start with, and the Docker image with the vulnerable application running on it, and the Netcat, which is going to be part of the Kali for the reverse shell connectivity, and Burp Suite to intercept the web requests and send the JNDI string in the web web header. And the POC code can be found from this GitHub list here. Yeah, I have already prepared a few things before we start this demo. I have rendered that Docker image, the vulnerable application, on one of my computer here, and so let's see if we can get to it. Um, okay, I have my Docker running on a one of my computer here, and this is and also the Docker it's exposed to the exposed on 8080. So I just go to here and you can see this. You can get to the web page, and this is intercept by the Burp Suite um, program here. So if I go to proxy HTTP, and I'm gonna send this to a repeater so that I can manipulate the web header, and then and send that request um, to the server. So what I'm going to do now is I am going to test whether um, the server is vulnerable to this log4j or not. So first of all, I'm going to use a burp collaborator client to do that. So I'm copying this collaborator, generated collaborator payloads, and this is an old one, so this is a new one. So I am going to put it in this JNDI string here, and I'm going to copy this whole thing um, into the header. So I just paste it right after the upgrade insecure request. Um, then I'm going to send this to the server. So let's see what's happening. I send this to, and let's observe the collaborator client. And as we can see, um, the server, when the JNDI string is sent to the server uh, query the DNS of the web collaborator. So here, that's the DNS lookup on this one. So if you can see this response back, that means that the server is vulnerable to the log4shell vulnerabilities, right? So what I'm going to do now is I'm going to close this, and I'm going to stop it before I get a response. I can. I'm going to craft the netcat command in the base64 format. So what I'm going to do is I'm going to issue this command here. I'm going to issue this netcat command here. So I'm going to echo out the base 64 string by running this command. So what it is echo just to output um, the base 64. So the N and NC is a netcat, and this is the IP address of my attacker machine, and the 444 is that's where the netcat will be listening on my attacker machine, and E-E is the executable, and I want to execute shell on the victim server, then pipe it to base64. So when I run this string, and I'll get a base64 um, command here, string here, right? And now what I'm going to do is I'm going to embed it into here, which I just did. Um, then I'm going to pass this JNDI string in the same request header again, right? So this time I'm going to pass it with the LDAP. So before I pass this through, I will start up the LDAP on my attacker machine, right? So this is what I'm going to do. Okay, I'm going to start up the LDAP machine. So the LDAP GNDI exploit snapshot jar can be downloaded from the link that I've shown in the PowerPoint slide before. So I'm going to run this jar to start up uh, my LDAP server here. So I'm just starting up. So LDAP server is listening on the 1389, and HTTP start listening on the 8888. Right now, Once I start this LDAP server up, and I am going to start up my listener on Netcat on the port 4444. All right. Now this is listening on the port 444 for any incoming on port. So once I get that done, I am going to pass this string into the HTTP header, like so. Okay, and let's see what's happening. And I'm gonna have it on side by side here. So let's see as soon as I pass that string to the server, what will happen on the screen here. Okay, so let's send through. There you go. I got a reply back, hello world, and it says, yep, connect to this from this. So now you have a shell on the victim server. So let's see. So who am I? Let's go ID, and I'm a root of that server. And if I go host name, and this is my Docker host name. It's not a real machine. It's a Docker. Um, and I can do pretty much everything on that machine. I can start enumerating um, the network and start recon on other server for any vulnerabilities. Then I can start, pivoting attack from this server. This is the server that I would do a foothold to it, and yeah, then yeah, this is pretty much a demonstration how easily to exploit this server if you have this um, vulnerability on your server. So, all right, now we come to the mitigation. How do we mitigate these vulnerabilities, right? Um, Simple is very simple to upgrade to 2.17, and 2.17, the log4j 2.17 it has the disables of the JNDI by default and remove the message lookup features. Um, for whatever reason, if you can't update the log4j to the latest 2.17 as um, as shown here, then you can go in and you can go and set the flag format MSG no lookups equal to true in the log4j config file. The log4j config file location can be anywhere depending on the vendor of the application that uses the log4j for the logging systems, right? So you just have to reach out to the vendor of the application to find out how you can mitigate these vulnerabilities. Um, some they will say, okay, upgrade it to the latest version of log4j, or some they will just come up with a patch on the application which would disable um, these features on the configuration file, or some of them they will say, look, you have to go into this particular location and set this flag in the config file, and you should be free from the vulnerability, right? And yeah, it's all depending on your vendor, how they utilize this log4j for their application. Yep. Thank you very much for watching. See you next time.